Hello everyone, today's session is all about Python classes. Python is an object-oriented programming language. Unlike procedure-oriented programming language where emphasis is on functions, in object-oriented programming language we mainly deal about classes and objects. What is a class? Class is a blueprint of an object, where objects are instances of a class. Object is simply a collection of data called variables and methods functions that act on these data. The process of creating this object is called instantiation. So how do we define a class in Python? In Python we define a class using a keyword class. So followed by a class name, which is as usual camel casing, followed by colon. So class is a keyword here, followed by class name, a colon. And coming to this triple quote string is a doc string, and here the doc string, this is my first class and this is a doc string. This is used for documentations for the classes as well as functions. So here these two variables are called class variables, class level variables, variable 1, variable 2, and this method is a class method. So class object supports two kinds of operations. One is object references and instantiation, attribute references. So let's go to the Python console. Let's type in class A, let's make some class name. It says my first class, colon, remember the colon after the class name, and let's declare one variable, variable 1 is equal to 1 and variable 2 is equal to 2. And try to write one method inside the class, def space sample underscore function, or let's make it sample, and remember the self keyword which we'll discuss about it later, and try to return hello or hi. Enter. Now that we have defined a class, so let's try some attribute references. So how do we do that? Say class name dot attribute name, say variable 1 here, enter. It gives me a value 1. Similarly, my first class dot variable 2 returns me a value 2. When you try to do my first class dot sample, should return me hi. So here you can see here my first class dot sample return me a function object, function my first class dot sample. Try to do my first class dot underscore underscore doc underscore underscore, it returns me a doc string. In here we don't have any doc string, so nothing printed here. Print, try to do so if you try to print, it gives me a none value because there is no doc string written there. Try to add a doc string for the above class, says class sample colon, enter. and have a triple quotations. That's how we have a doc string. This is my sample class. Enter and try to pass it. So how do we get this doc string? So we can get this doc string by using class name dot. In here, class sample underscore class dot underscore underscore doc underscore underscore. This is one of the special method to get the doc string. So here you can see here we got a doc string here. This is the sample class. This is how we get a doc string from a class or a function by using underscore underscore doc. So here it says it returns the doc string. So coming to class instantiation using function notation. So how do we instantiate a class? So instantiation of a class use the following syntax. Let's go to the Python console. Let's type in obj. Obj is object here for the class my first class. This is how we instantiate in Python. Enter. Instantiation, it's like a same function syntax. You can see here when obj enter, if you try to do obj enter, it says main my first class object. Obj dot variable 1 should return me a value 1. So we are trying to access the class level variables using objects. So obj dot variable 2 return me a value 2. So in here we can see here we got the values from class level by using class name, also from a object. So obj dot sample return me high. You can see here from the above, my first class dot sample return me a function object, but obj dot sample gave me a return statement. Class methods have only one specific difference from ordinary functions. Object itself is passed as self argument. Obj dot class name, which is implies to my first class dot class function of object. So we are passing an object. So self, what is self here? Self in here takes the object as an argument. Since here my first class dot class function name of object is equivalent to creating an object dot function name. So if we try to do my first class name dot method name of object should return me high. So my first class there is some hang here, so wait a bit. My first class dot function name is sample. Try to pass object as an argument. It return me high. You can see here, which is equivalent to obj dot sample. This is the significance of self in Python. Constructors in Python. So what are constructors? Methods that begin with two underscores are called special class functions. Def __ init _ of self is a constructor in Python. Whenever a new object is instantiated, a constructor is called. Constructor is optional and we are not providing any constructor when Python will provide a default constructor without arguments. Self is by default in Python class methods. So we'll be writing self by default for every method inside a class. So that is a basic difference between a function and a class method. So class method will be having a self inside that. So try to copy that. So class example1 with a default constructor without arguments. Enter. So try to create an object. Say obj1 is equal to example1. So how do we create an object here? Example1 parenthesis. Enter. Obj1 dot variable1 should return me value 1. So let's go to the constructor with arguments. Let's try to copy this complex number example class complex number. There is some issue with the indentation, so try to redo that. Please take care of the indentation. Enter. And you can see here we have written one class complex number. Try to create an object. Object2 is equal to complex number. We'll create an object. Enter. And we are passing arguments to this constructor. So how do we pass arguments to the constructor? Class name. Inside the class name in arguments we will be passing the parameters for this constructor. So in here constructor takes 2 arguments, so we did pass 2 arguments to the class name. So object2 dot real return me a value 5. You can see here we passed 5 as a first parameter and 6 as second parameter, which is stored inside self.real. So obj dot imag gave me a value 6. You can see here we have written self everywhere. Self in a Python class. Self represents the instance of a class. By using a self keyword we can access the attributes and methods of a class in Python. It binds the attribute with the given arguments. So it's a bit like a this keyword in Java. So when you try to access variables inside the class, we use self dot variable name. When you try to access class methods inside the class, we will be accessing through self dot method inside a class. So what are class and instance variables in Python? Class variables are shared. They can be accessed by all the instances of that class. There is only one copy of the class variables, and when one object makes a changes to a class variable, that changes will be seen all over the instances. Object variables are owned by each and every object or instance of a class. In this case, each object has its own copy of the field, that is, they are not shared and not related in any way to the field by any name in the different instances. Let's have one example. Say class dog kind is equal to canine. This is a class variable shared by all the instances, and you can see here self dot name is equal to name. This is an instance variable which is unique to each instance. So let's go to the Python console. Yes, guys, that I'll try to type in, say class dog, let's say class country colon, let's have one constructor or a class variable country underscore name is equal to India. Let's have one constructor def underscore init underscore and pass in self as a first argument, comma cname colon, self dot cname, self dot country name is equal to cname. So you can see here class variable country name and an instance variable country name, and also have a self.cities is equal to have a list consisting of cities. Let's say Dallas, Austin, and enter. Let's create an object for the country class. So how do we create an object? Country, or try to access the class variables. Class name dot variable name gives me the output, country dot country name, country dot cities. You can see here there is an attribute error. Type object country has no attribute cities because cities is not a class variable, it's an instance variable there. So let's create an object obj1 is equal to country. Let's pass in arguments for the constructor. Let's say US. So we create an object obj1 for the country class. So obj1 dot country name should return me US. You can see here instance variable change when you try to pass US. It's going and hitting the instance variable, not the class variable when you try to access with the object. obj1.cities gave me Dallas and Austin. So we are able to access this instance variables by using objects, by using instances. So country dot country name return me India because India is a class variable there. Sorry, country name is a class variable there. So let's create one more object obj2 dot. Let's create one more object obj2. Passing an argument Russia there. So try to access obj2 country name, it should return me Russia there. So obj2 as an instance variable return me Russia. You can see here instance variable differ for each and every instance, but class variable is same for all the class, for entire class, and class levels are copied only once. This is the major difference between a class variable and an instance variable. Let's go to the command line, take a fresh Python console. Let's try to copy that. Let's try to write a class method. Class method takes a decorator with an argument CLS. So decorator class method def space change class variables. So by using class method by using only class method we can change the class variables. So you can see the syntax for the class methods. Class method takes in the decorator class underscore @ class method, and inside the function definition change underscore class variable we are passing CLS as the first argument, which makes it as a class method, and we are passing one more, a new cname. So we are changing class cls.country_name is equal to new cname. So try to call in that class method. So country dot, you can see here country.country_name gives me India. When you try to change class variable by using class method, so create a object obj1 is equal to country, pass in US, obj1.country_name, country name give me US. So let's try to change this class variable. Class variables can be changed by using class methods. So how to access these class methods? By using class. So country dot change class variable and pass in new cname as France, and try to access the class variable. Country dot country name should give me France. You can see here we have changed these class variables, which is throughout the scope of that class. So the class variable has been changed by using a class method. obj1.country_name still give me US, but if you try to do country.country_name, it will give you France, because we have changed the entire class variable. Let's try to do few more things. Let's try to add in static method. Static method syntax, it uses the _static method decorator def method name. You can see here static method do not take any arguments, but class method takes a default argument CLS as the first one. So the first argument, make it as cname colon, if cname is equal to make it as US, and the if block, so return true, else return false. Just try to run this. Country dot country name use India, so try to check the static method. So country dot we shall try to change this class variable to US, enter. So we have changed the class variable to US now. Now try to check it. Static method country dot country_check. It should return as true. We are passing US as an argument, and you can see here we got a boolean saying it's true. So we have successfully changed the class variables, and also discussed about static methods in Python, and class methods in Python, and instance methods in Python, and also a constructors in Python. So let's try to add some docstrings for the constructor. And for the class method, as a docstring. And coming to static method, try to make it a static method as a docstring. So try to add one more method to make it as an instance method. Say def country underscore name, taking an argument cname, country name, change, taking an argument cname, and this is an instance method. You can see here we have discussed class name method, static method, and instance method, and a constructor. This class consists of all the 4 items. Instance method takes the first argument by default self. So if cname is equal to US, try to return the country name, self.country name. Inside the instance method, we need to refer it using self dot for the instance variables. Else shall try to change the country name. Self.country name is equal to cname. Try to run this class. And class methods. So try to make some differences between class method, static method, and instance method. The class method takes CLS as the first parameter, while the static method needs no specific arguments. So you can see here in the class method, CLS is the first parameter. Inside the static method, there is no first parameter, and instance method, there is self as the first parameter. So a class method can access or modify class state, while a static method can't access or modify it. Instance method can access or modify object state. You can see here inside the class method we have modified this class variable. So we can modify the class state of a class by using class methods. So static methods can't change any state of the class, and instance method also cannot change the state of the class, but it can change the object state by using self. In general, static methods know nothing about the class state. The utility type methods that take some parameters and work upon those parameters. On the other hand, class methods must have class as a parameter. Instance method requires object to be passed as an argument. We use class method decorator in Python to create a class method, and we use static method decorator to create a static method in Python. You can see here class method is a decorator and static method is a decorator there. Inside class method, referencing is CLS dot attribute name. Inside instance method, referencing is done by using self dot. There you go. CLS dot country name, now to reference a attribute name. So in instance method, the reference is done by using self dot country name. So let's go to another topic, create a calculator example using a class. Write a class calculator. Creating a constructor, def init, taking two arguments, a comma b, self, try to take in those parameters, self dot a, self dot first number is equal to a, self dot second number is equal to b, let's try to create one more method, def add method. As I said, instance method always takes first argument self in Python. Try to return self dot first number and plus self dot second number. So this add method will return the summation of first number and second number. Def sub self, it will return the subtraction of first number minus second number. This is on some of the basic example using class. Similarly, def multiplication, it will return self dot first num multiplied by self dot second num. So let's create an object for the class. Obj is equal to calculator parenthesis and try to pass arguments 5,4, enter. Obj dot add should give me 9. Similarly, obj dot sub should give me 1. So obj dot mul should give me 20. So this is how we call the instance method using objects. So coming to the notepad again. So how do we delete Python class attribute and objects? By using del. Del is the keyword that is used for deleting class attribute as well as objects in Python. So deleting class attribute, del d.kind, deleting class objects, del d, deleting class. Let's go to the Python console. Go back to the Python previous terminal. Adjust few things here. So here you can see here country name is a class variable. So we are trying to delete that attribute name, del country name should delete the attribute name here. Enter. You can see here it returned me nothing. When you try to access it, country name should throw me an error. You can see here error, Attribute error, type object country has no attribute country name. This is because we already deleted the class attribute. Let's try to delete an object here. As you can see here, obj1 is one of the objects we created in the earlier session. So try to delete the class object. So del space see here, obj1 is one of the object we created. So del so create a new object, obj12 is equal to country. Let's say it as path. Try to check the instance. Each instance is a method which will tell us like whether a given object is an instance of that class or not. So obj12, so it returns me a true value. So it says that obj12 is an instance of a class. So let's try to delete obj12 by using del keyword. So del space obj12 should delete the object. Let's try to check that each instance of, it says name error, name obj12 is not defined because we already deleted that object using del keyword. Similarly, try to delete the entire class itself. Del country will delete the entire class. So let's try to create an object for the class which is not there. Let's give country name as Japan. You can see here name error, name country is not defined. Whenever you use delete keyword, name error rises if the object is not there, object or class or attribute is not there. So what is each instance method does? Each instance method takes arguments like first argument as an object followed by a class name. It will check whether the object we have passed is an instance of that class. It returns a boolean value either true or false. True means that object is an instance of the class, or if it is false, it says it is not a instance. So it returns true when the given object is an instance of a class. So what are inner classes in Python? So we can declare a class inside another class. Such type of classes are called inner classes. Without existing one type of object, if there is no chance of existing another type of object, then we should go for inner classes. So let's take an example. Say class outer. Docstring says outer class. We have a constructor. Initializing self.inner is equal to self.inner. We are creating one more object for the inner class, inner. So self.inner will instantiate inner class there in the line number 267. So let's try to run this program in the console. You can see here we have inner class here, class outer and class inner. So how do we create an object? It's in the same way how did we do previously? So outer is equal to outer. Try to access this reveal method, outer.reveal. You can see here, calling inner class function from outer class. So while instantiating, it is creating one object for the inner class. So whenever we call this reveal method, it is calling the inner display method from the inner class. So that calling inner class function for outer class is passed as argument for the message, and we are trying to print message there. So how do we call the inner class method directly from outside? So outer.inner display, we can call it directly from outside. You can see here the output calling the inner class method directly. So how do we are trying to create an object, inner is equal to outer of inner will create the object for inner class only. So when I try to print inner, see it says main outer dot inner object. So inner underscore display, we are trying to directly call the inner display method from inner object. So inner display will try to pass some string, checking the inner method. You can see here the print statement return me checking the inner method. Instantiating the inner class. You can see here inner is equal to outer of inner is equivalent to creating. You can see here it is more efficient here in this line number 299 than this line number 288, where we are calling outer dot inner display, which is less efficient. So let's go to another topic, multiple inner classes. You can have more than one inner classes in a class. Then it is called multiple inner classes. You can see here in this example, class outer has two inner classes. It has one constructor and one inner class and another inner class. So outer has two inner classes. So it makes it as multiple inner classes. So try to, and one more thing is multi-level inner classes. In multi-level inner classes, the inner class contains another class which is inner class to the previous one. It's like multi-level inner classes. You can see here in this example, class outer has a constructor and it has an inner one class inside it. And coming to the inner one class, it has one more class inside it, making it multi-level. So inner one class has two classes inside it, multi-level inner one and multi-level inner two. So Python supports both multi-level and multiple classes. So coming to this multi-level inner class example, so let's take one task. Create a single linked list with add, search, remove element method. Example, 9 is pointing to 11, 11 is pointing to 13, and 13 to 8. Let's make a single linked list using classes and instance methods. Let's try to have add method inside this single linked list class. Try to add 45. Remove an element, remove 11. Search method, search for 13. So let's try to do this example. So create a single linked list with add, search, remove element methods. So class, start the class node, which will create a single node. So we are having a constructor in it, which will initialize the variables data, next, as well as previous. So self comma data, write a docstring which clearly explains the necessity of that node class, creation of node. So self dot data is equal to data, self dot next is set it to none, and same way self dot previous is set it to none. So we are initializing a node and setting the data and setting the next and previous as none. So write a single linked list class single linked list colon just write a constructor def init self comma and docstring says creation of single linked list. And docstring says single linked list with predefined methods, add, search, remove element methods. So self dot head. Initially we shall point self dot head is equal to none. So try to add one more method, say add self comma data so whenever you are trying to add a node to a single linked list, so we should create an object for the node class and pass data as an argument to that class. So this will, line number 22 will create an node and we need to link it to the next as well as previous nodes. So if self dot head is equal to none, so that says there are no elements inside this single linked list. If there are no elements inside the single linked list, let's try to do self dot head is equal to node if there are elements inside the list, try to add it. say self dot say node dot next is equal to self dot head and node dot next dot previous is equal to node dot prev node. And self dot head is equal to node. Let's try to add one more method, say search method. So def search for some key, comma search key, let's take one a variable called x is equal to self dot head. So if not equal to that search, so if x not equal to none, then it says there are no elements inside that single linked list. Sorry, if x not equal to none, it says there are elements inside this single linked list. Then we need to trace that element by using loop. So we wrote a while loop, while dot next not equal to none. If it is not equal to none, then we are trying to iterate it. And if x dot data is equal to search key, then return true. We are trying to return the x here. Else x is equal to x dot next. We are trying to iterate it to the next node. So if x dot data is equal to that search key, we'll try to return the x there. This if block will be executed if there is only one element inside that list. So we are trying to return x. Let's save it and try to run it. So if x not equal to none, it will iterate through each and every element and find out the search key and try to write one more method, say def remove self comma element. Let's take one a variable called temp. Temp is equal to element dot prev. Let's try to finish this remove method. Element dot previous is equal to temp. We are trying to swap these elements. So coming to the main method, try to create an object for the single linked list. Object name is SLL is equal to single linked list. So SLL will form an object for this class single linked list. So SLL dot add method, we are trying to call the add method by passing the value nine. SLL add one more element called 11. SLL dot add one more element 13. SLL dot add one more element, add 8, and try to print the single linked list. Print SLL, enter. Let's try to save this and run it in the console. Open the command prompt, go to the directory, cd space try to get the directory, cd python underscore findings, class1.py. You can see here we have a single linked list.py. Let's try to run that. Python space single linked list.py, enter. You can see here it returned an object consisting of single linked list. So let's change few things in there. Try to add one more method, say def traverse, take a while loop, usually traverse through each and every element and try to print the data. Say while x dot next not equal to none, try to print the x dot data. Node is equal to self dot head. So while x not equal to none, print x dot data and try to iterate x is equal to x dot next, print x dot data. x is equal to x dot next. So try to save it and run it by calling the sll.traverse method. sll.traverse method, which will print all the data inside that single linked list. Let's add one more print statement. Print elements inside the list, inside the single linked list class. Try to run the, you can see here elements inside the list 8, 13, 11 and 9. So it travels through each and every element inside the single list and print that element. So sll.search method, try to search for element 13. Before that, we need to change few things in the search method. Adding a print statement search key. So try to add one count. So try to return the count. So save the changes and try to run it. We are searching for the key 13. Try to run this. Python space single linked list.py. You can see here in the output search key is printed at the position 2. So we are searching for the key 13 and says it is present at position 2. Try to change it. Let's say 8. Save it and run it. You see here search key is present at position 1. Same way search from push 9 says search key is present at position 4.